Our next talk is about smart dust mitigation solutions for PV systems. It's going to be presented by the Assistant Professor and Chair of the Mechanical and Energy Engineering Department at Imam Abdulrahman bin Faisal University. Please welcome Dr. Nasir Hariri virtually.
Good evening and hello to everyone. Welcome to my presentation. Thanks for the introduction. I hope you can hear and see me as well with no technical issues. It's my pleasure to join you today virtually. My name is Nasir Hariri, the Chair of the Mechanical and Energy Engineering Department here in Imam Abdulrahman bin Faisal University at the Imam, King Abdulaziz Saudi Arabia. So far, it has been a nice robotics event that we enjoyed all. And since my talk is at the end of the second day, I will not keep you for long, and I will briefly share some of the effort that we have concluded that is related to a robotics system that we have also developed in the past. Again, I'm very happy and excited to join you today and to share some of our recent research effort toward the development of a smart and sustainable technologies. My presentation has the title of a smart dust mitigation solution for PV system. Here is an outline of the presentation. We'll start with a brief introduction to highlight the main motivation of this research. Then we will discuss briefly some of the background regarding the dust accumulation issues for photovoltaic system. Then I will be presenting the developed system for both autonomous cleaning robot as well as the proposed self or smart self-cleaning system for PV application. And we will briefly highlight our previous studies for the control of the SMA-based actuators, as well as other robotic system, that if we get the time at the end of the presentation. According to the Center for Climate and Energy Solution in the United States, demand for renewable energy has increased by 100% from 2000 to 2018, which demonstrates, in fact, one of the fastest growing energy source in the United States. Globally, renewable energy made up to 26% of the global electricity generation in 2018. And this has jumped already to 28% in the first quarter of 2020. And recently, an all-time high of about 30% in 2021. It is expected to rise by 45% in 2040, where most of the increase is basically coming from solar and wind systems. In addition, according to the Global Energy Review report released last year by the International Energy Agency, renewable electricity generation in 2021 is set to expand by more than 8%, which indicate the fastest year-to-year growth since 1970s. It was also stated that the energy of the solar PV and wind are set to contribute 2/3 of the renewable energy growth in the global electricity generation. However, although the enormous benefit of using solar energy sources to create or generate clean energy worldwide, there are different factors that we notice, and it's being globally highlighted as well, that significantly hinder and affect their overall efficiency and performance. One such factor is the dust accumulation on the surfaces of PV panel. As can be seen from the world dust intensity map, that the MENA region, which is Middle East, North Africa regions, has one of the highest dust intensity in the world, while practically desert areas are better suited for large solar PV farms due to the availability of the large installation areas for solar panels, as well as availability for the solar radiance through the year. Weather conditions such as sandstorms and dusty weather in a desert environment can significantly degrade and hinder the system performance, where there is, where they basically affect the many elements in the system, either reducing the system performance or the efficiency of the system, as well as the expected lifetime of the solar panels themselves. Now, there are many recent, we'll go through that background briefly just to highlight that many recent studies explored already the effect of dust accumulation to the performance of PV panel. A recent study conducted by Ramiel and his research team investigated that the output power reduction of a PV panel due to the dust accumulation on the surface varies with the weather condition. Experimental result from this study, as well as other study, has indicated that PV power losses for 2 weeks test was about 10%, which is kind of significant. During the 4th week test, they noticed that a significant drop on the power or the electrical performance of the PV panel was noticed of about 80%, And this is mainly due to a sandstorm event that occurred during the collection of these experimental data. In this case, the condition of the PV surface was determined as being extremely dusty because of the decreased power output, and the cleaning process is required at this stage. And that's really what moves us into the different studies that have highlighted the effect of PV cleaning processes and method available in the market in reducing the power losses due to the soiling and dust accumulation. For example, Research Young has proposed a model to estimate the cleaning frequency for PV modules to maintain a higher power output of a solar PV system, especially in desert environment. This model highlighted the necessary cleaning period of about 20 days with a power reduction of within 5% and a practical concentration of 100 milligram per meter cube. Also, another researcher, Zahidi, and his team has reviewed and provided us a comprehensive summary of recent researches on the necessary cleaning frequency of PV system across different locations worldwide. For example, Middle East and north of Africa, south of Asia, as well as general desert regions worldwide. The results have indicated a range of starting from a weekly to an optimal of 20 days is recommended for the cleaning intervals in the highlighted regions of. Now, it is necessary to note that minimum improvement in the PV system and their operation offer massive gain in revenue. Therefore, dust accumulation is indeed a common and dominant obstacle for most places, especially remote installation sites where PV systems are located. In the meantime, mostly common method for cleaning flat PV panel are natural sources such as the rainfall, also manual cleaning method that depends on the labor and manpower for the cleaning process, in addition to automatic cleaning system that include robotics devices. Other water-free or waterless method include coating material to reduce the amount of dust particle on the panel top surfaces, as well as surface vibration method, such as the cleaning using a linear piezoelectric vibrator system and ultrasonic cleaning system in order to remove and eliminate the dust particles. Despite the different available methods for cleaning, the majority of these methods depends primarily on the need for electrical energy in order to operate these systems, which in general make PV system more expensive and less efficient to use due to the electrical consumption associated with these particular technology solution. And that's now our main objective in our ongoing research studies that we are sharing today is to develop an innovative smart cleaning method that offer a technology solution for dust removal application. And this has been approached by two main development that we are sharing today, which are the design, integration, and development of a low-cost, fully automated cleaning robot for PV dust removal application, as well as a smart and novel cleaning method that offers self-actuation, self-cleaning operation for PV dust removal application. And that's the second part that we will cover. So far, for the first development of a low-cost, fully automated cleaning robots, and there are a lot of ongoing effort that we are doing here in the department, me and my colleagues, as well as my SDB student, to develop a low-cost solution for the cleaning process of PV panel. This is some of the ongoing effort for the development of the automatic and robotic PV cleaning system. And again, traditional experiment setup were initiated to include the CAD model of the robot, as well as the necessary electrical setup, and as well as the embedded control system integrated within these robotics, which include, again, multiple sensors, multiple actuators, such as rotary encoder, actuator, and so on to operate the system. And here is, if we can see the demo, hopefully you can see the video from your end as well. So we can see this is one of the first trial demo or approaches that we initiate using this design of a low-cost robotic system. Then after that, multiple enhancement, multiple improvement to the system has been achieved in order to optimize and its operation, as well as to cover the cleaning area for the PV panel by 100%. In this system, a closed loop control system was utilized in the form of a simple PID controller in order to maintain the velocity or the speed of that robot throughout the cleaning process for the system. This is again 2 photos of the same dusty PV panel before and after one dry cycle of cleaning using the autonomous cleaning robot. The system is now being also updated to incorporate a water-based cleaning method with the use of a pump. Future work regarding the electrical performance and the cleaning metrics are currently being investigated right now. Now, this moves us to the interesting part of today's talk, which is the new cleaning methodology, which is the development of a smart cleaning method that offer a technology solution for self-actuating, self-cleaning of a PV system. Just before we jump into the developed design, a very brief background of SMA will support the applied methodology that we will introduce. Our proposed method utilizes a unique alloy called shared memory alloy in the form of an ethanol wire actuator, which is made of a nickel and titanium material primarily. The SMA has a unique thermomechanical property called the shared memory effect and the superelasticity. Simply, once the material is being heated from the one phase, which is the martensite phase, into the austenite phase, therefore, through that phase transformation process, the alloy, the ethanol wire actuator allowed to generate a recovery forces as well as a contracting by a 5% of its original length. So we use this important criteria or unique criteria within the SMA wires previously in different applications. In the past, my team and I have studied the possibility of actively control the SMA wire actuator, where our previous study showed accurate control of a recovery force and position of the wire actuator by developing again scheduling PID closed loop control system. It is very known that these material or these type of an actuation mechanism are nonlinear due to the hysteresis behavior within their phase transformation process. And therefore, again, scheduling one type of a nonlinear control was utilized in order to achieve a precise control through a long duration test of 50,000 cycles as shown over here, with precise control for the displacement of the SMA spring. Therefore, then studying the feasibility to embed the ethanol wire into a thin elastic membranes made by a high-performance silicon rubber material in order to simulate basic movement of facial muscles, where we were able to achieve single and double motion or double bend motions, as shown at the middle part of the slides. And we were able to achieve it also experimentally and validate that. Now, we utilize the same approach, we utilize the same concept, and therefore our main research question becomes that we are trying to find a solution for, can we utilize the available excessive thermal energy from solar panels and harvest it in order to generate effective mechanical energy to overcome the dust accumulation issue? In other words, a possible smart self-cleaning system that does not depend on electrical energy to operate, while rather it utilizes the thermal energy that is available with us within these PV systems. And that's what we looked into, and also presented in the article that was accepted recently with the title of a novel dust mitigation solution of a self-cleaning method for PV module capable of harnessing rejected heat using shared memory alloy. So the methodology is basically utilizing the solar radiance applied to the top surface of the PV panel, and then from the sun rays, this will generate a thermal energy applied at the back surface of the PV panel, and therefore, with an embedded SMA wire arrangement, as can be seen over here, at the back surface of the PV panel through the unique thermomechanical property exists with the SMA alloy, and effective mechanical energy is available and can be extracted from the system. And that's the methodology of the whole smart cleaning system that is being proposed. And here is a video or a demo demonstrating the successful achievement of the proposed smart PV cleaning system. Is basically, this system is now under the sun simulator instrument, and we have a PV panel with the wire arrangement at the back surface, embedded at the back surface of the PV panel. And while the temperature is gradually increased to reach the steady state response within the system, we can see that the SMA wires start to be activated. And that activation is driving this cleaning bed or cleaning bed of the linear mount that we have over here to clean the PV panel with, again, no electrical energy associated with the system, only purely utilizing the heat applied to the PV panel, and the SMA unique property exists with the cell. So in conclusion, overall, the presented development presents a sustainable solution related to a self-cleaning mechanism for solar PV system in various aspects, where it can be concluded that a proof of concept that uses a thermal energy as an energy source for the operation of the cleaning PV system is successfully achieved. And this is primarily a study. Now we are doing more advanced development for a real life scale of the system itself, in order to design it with a piston-like mechanism to drive the whole cleaning bed for an actual size, a full-size PV module. And since this conference is about something we all love, which is robotic system, and before I end, I will share briefly some other robotic system that we also developed here in the College of Engineering. For example, active closed-loop solar tracking system. In this study is basically not only studying the performance or the electrical performance of the single axis as well as double axis system and compare it to a fixed axis or fixed PV panel, but also investigating the effect of solar tracking system on the thermal profile for the photovoltaic module. And that's something that was very interesting to highlight, that while these dual axis trackers are being utilized, PV panels are gaining more thermal energy due to the fact that the sun rays are facing the panels throughout the day. And we noticed that a 3% increase in the temperature for the single axis compared to the fixed, while a 5% increase in the temperature between the dual axis and the fixed PV panel. So that was one of the robotic systems that was designed and developed here in the department. And also previously, there were few other development related to aerospace, and I took the motivation to add these slides since I saw from the first day we have some expert in the aerospace field. So this is a previous study regarding vision-based navigation for electromagnetic formation flight. It was a partnership with NASA, as well as my previous affiliation or institution, Florida Institute of Technology. Is basically development of a closed-loop electromagnetic flight formation using the RINGS, resonant inductive near-field generation system, as well as the newly developed vision system, which is called the smartphone video guidance system. And it's basically this system, the SVGS, was developed by NASA Marshall Space Flight Center. It utilized basically a smartphone as well as a target, and it compute and estimate the position variables or state variables for the system. So it basically gives you all the three linear position states as well as the orientation states for the system. And therefore, we took the collaboration in terms of utilizing this system for the first time and incorporate that into a robotic system to provide the necessary feedback signals, both position as well as velocity. In order to build the full state feedback control algorithm. And then we were able to demonstrate few path following trajectory application. Again, this is the ring resonant inductive near field generation system. Is basically a platform to demonstrate the possibility of being able to not only transfer the power wirelessly through the coil, integrated coil, but also the ability to perform flight maneuvers and control between two different aircrafts as shown over here, and we'll highlight it in the next video. So again, different control strategic were applied in this application. We applied nonlinear control approach, such as the sliding mode controller. We applied also the LQG, linear quadratic Gaussian control algorithm, which basically an LQR plus the Kalman filter for the state estimation process to provide more accurate estimate of all the state available within the system, using the newly introduced the SVGS system. which basically the smartphone, as well as a target installed on the moving aircraft. So here in this setup, we have two SVGS systems. The first SVGS is relatively stationary to the workstation, and the other SVGS system is installed in one of the aircraft while the target is being mounted on the second aircraft. Now, if you can look into this demo, it will clarify how the process was achieved in this example. So right now, what we applied here is just a disturbance test where we move the two systems from their set points, and then we can see how effective were the control or the controller in order to bring these responses back to the regulated values for all degree freedom. So this was part of the initial development. Then eventually we're able to demonstrate and implement a path-following controller. Basically, it performs a coaxial and collinear maneuvers as shown over here. I think if you can this video. So basically, you will see in real time now both aircraft are following these trajectories, the first aircraft as well as the second aircraft, and completing and tracking the precise path that we defined. The majority of these data that we performed previously are available through multiple article papers. This one primarily is the proximity operation and 3-degree freedom maneuver using the smartphone video guidance sensor. So again, using that system, the smartphone with the target, we're able to demonstrate the possibility of being able to control different aircraft or different robotic system and position them properly as desired. At the end, I would like to thank the research team here at the Renewable Energy Laboratory in the Mechanical and Energy Engineering Department at IAU for the detailed discussion, as well as the Mechanical Workshop and the Fab House Center at the College of Engineering for the support in the experimental phase of many projects here related to research, as well as for our SDP students as well. And I would like to take the chance to highlight that this project, in fact, the mechanical workshop and many other laboratory are equipped with the state-of-the-art machines, such as the 3D metal printers, as well as advanced laser cutting instrument that we have in our mechanical workshop. And now we were able to create a website where we are capable to receive work orders from different institutions outside the university. So if you are interested for manufacturing process, for any kind of collaboration in terms of manufacturing for robotic system as well, please feel free to utilize this for your use as well. Here are some of the references that we use in this presentation. Again, I would like to thank all of you for joining us today and having me as well. Thanks for the organizing committee chaired by Professor Eric, Michael, Shunta, and I hope to hear and collaborate with many of you and the audience who share the same research interests and potential collaboration. We are here, ready, and always looking for collaborative cooperation. Once again, thank you.
Thank you, Professor Nasir.